Today we are learning about direct variation, and we're going to learn how to write and interpret direct variation equations. Now, some relationships are directly variated. That means that there is a relationship between some quantities, and the ratio of the values is constant. And when we think of direct variation, we think of this. This is the equation that we usually use, and it looks something similar to slope-intercept. If you notice, the difference is, if you notice in slope-intercept, our y-intercept is 0, so it has to go through the origin. So that value, the y-intercept, this is always 0. We don't write it because it's understood. And then K and M are your constant. And one way you can look at it is, I always think of as one increases, the other increases, or one decreases, the other decreases, because they are directly related. And so we're going to look at this example to determine whether or not the relationship is directly related. So we have this table of values. One, 3, 4, 2, 6, and 8. And we have to find out if this represents a direct variation. So first thing you want to do is find out if there is a constant. And if you look back at our main equation, to find your constant, if you solve for k, if you notice, you would divide both sides by x. So anytime you're given a table of values, all you have to do is divide your output values by your input. And if you notice, if we do this for each case, y over x, 2 over 1 is the same as 6 over 3, is the same as 8 over 4, and all of these equal 2. So that means there is a direct variation between y and x. Y varies directly with x, and k, which we just found, is equal to 2. So the equation would be y equals 2x. That would be your function rule. So that means that in order to find your output, you would do 2 times your input. 2 times 1 is 2, 2 times 3 is 6, 2 times 4 is 8. Okay, try this guided example. For each function, determine whether y varies directly with x, and if so, what are the constant of variation and the function rule. Okay, on the left side, what I did was I divided my y values by my x values to see if there was a constant, and I noticed that each pair divided to give me -7. So yes, y varies directly with x. They wanted to know our constant of variation, so k equals -7 because that's what the constant value was. And then they wanted a function rule. Well, my function rule will be y equals -7x. And that comes from y equals kx, where we just plug in our constant value. That way, we can use that equation to find any term that we needed. Now, let's look at b. If you tried b, and you did y over x, you're going to get 5 over 2, 7 over 3, and 13 over 6. If you notice, these are not equal. Therefore, you would say no, that y does not vary directly with x. So it won't always work, but you always want to check to make sure and try to see if there is a constant. Okay, let's look at these two examples. We're identifying from equations because what we've done is identified from tables. And when there's an equation form, you want to see if you can get it into y equals kx. You got to remember now it has to be in that form, or x equals ky, doesn't matter. And you want to basically, I always say, get y by itself to see. So in this first example, if you divide by 3, you'll get y equals 7/3 x. Well, this is the same form as this, where k would be 7/3. So this one would be yes. Now over here, if we divide everything by 7, you're going to get y equals 2x plus 1. Now it looks similar, but if you notice, we have this plus 1 here. Remember I said our y-intercept is always 0. So because of that plus 1, this one is no. Now you try these two. So we're going to try these two examples. You can pause and make sure you get it, and then we can check our answers. Okay, on the left, I got y by itself. Ended up y equals negative 5/3 x, which looks like our direct variation rule. And so I said yes, k equals negative 5/3. B, if you notice, was already in our form. I just rewrote it so you can see that there is a 1 in front of x, so you can make it 1/9 x. So this is also, yes, a direct variation, and k is now 1/9. Okay, you can also use proportions to solve direct variation problems. So let's say that y varies directly with x, and y is 9. When x is negative 15. What is y? When x is 21. So if we remember, if it's direct variation, y varies directly with x. Y over x is constant. So it's always y over x. So when you set up your proportion, you're going to do 9 over negative 15 is equal to, we don't know y, when x is 21. And then you would use what we call cross multiplying. So you're going to get negative 15y is equal to whatever 21 times 9 is. So that's negative 15y equals 189, and if you divide by negative 15, y equals negative 12.6. So that's an example of using proportions. Now you try this one. Suppose y varies directly with x. Y is 15. When x is 3. What is y when x is 12? Okay, so go ahead and try it. Okay, if you did it right, make sure you set it up as y over x, because that's the constant. So 15 over 3 is equal to y over 12. Cross multiply. And when you solve for y, you get 60. Let's look at a real-world example of using direct variation to solve a problem. A salesperson's commission varies directly with sales. For $1,000 in sales, the commission is $85. What is the commission for $2,300 in sales? So what we want to do is find our constant, and I'm going to rewrite our equation here so we'll know. And remember, to find the constant, we have to divide our y, or our output, or our dependent variable, over our x, which is your independent variable. And to help you, I'm going to use letters that correspond with the word problem. So it says commission, I'm going to use C, varies directly with sales, and I'll use S. So for $1,000 in sales, so over here, this will be C over S. The commission is $85. And if we divide that, that means our constant is 0.085. So then going back to our equation, we have C equals 0.085S. What is the commission for $2,300 in sales? And now all you have to do is plug in $2,300 for S. So that would be $195.50. And get in the habit of doing that, finding your K or your constant, writing your direct variation rule, and then answering the question. So let's try another one. This one says, the number of calories varies directly with the mass of cheese. Number of calories varies directly with the mass of cheese. I'll just use M. So I'm going to let you see if you can find K, write your direct variation rule, and then answer the question. Oh, let me finish reading. If 50 grams of cheese contain 200 calories, how many calories are in 70 grams of cheese? Okay, so I first found K by dividing C over M. And then I wrote my direct variation rule. And then I plugged in the information they gave me. And I answered the question. Very important. And write your units. Now, some of you all may have used proportions to solve for K. That's fine as well. So you could have done, or you could have found the answer using proportions, but you want to get in the habit of writing the equation, doing it this way, so in case this acts like this on the quiz, you'll know how to do it. Okay, our last concept in this lesson is graphing direct variation, and I just want to touch on this a little bit so you'll understand. Remember, in the previous slides, I mentioned that direct variation comes in this form, and our y-intercept is always 0. So that means that when you graph it, your graphs will always go through the origin. And so if you think about it, for example, if you had to do y equals negative 2x. Now they're going to ask you to make a table of values so you can see what is going on to the graph as you're plugging in table of values. I don't really like doing a table of values because I think it's kind of time consuming. So I'm going to show you both ways. You can do a table of values, -1, 0, and 1, and you plug those in to get your output values, which would be 2, 0, and -2. Another way you can do this is, if you remember, this is slope-intercept. So you can start at 0 and then use your slope, which is -2 over 1, and go down 2 over 1. Or if you did the table of values, you would plot -1, 2, 0, 0, and 1, -2. And then you just draw your graph. So all direct variation graphs have to go through the origin. I'm just going to point to it. Right there. They have to go through there. And then if you have a positive slope, of course, it would be facing this way. But it has to go through the origin. And then basically, that is your lesson.